Hey guys, and welcome to Functional Print Friday, and welcome back to my shop. So a couple of weeks ago, I showed a proof of concept for a design I came up with to print a TPU bellows structure completely flat down in the bed like this. And the way that I achieved that was designing this with just a zigzag shape and letting the slicer place a single layer of PLA as an interface layer between each one of these pleats on both sides. And PLA sticks to TPU well enough to print, but after the print's done, you can peel it off pretty easily and you end up with just a TPU structure. And this worked out really well. And since then, I've been thinking about other ways to apply that. So about a year ago, I grabbed our checkbook to pay the yearly property taxes here. And when I went to open it up, the cover completely split into two pieces up here at the spine. And I've had this for a long time, so wasn't particularly surprised by that. And I thought, you know what? I'll pop up onto Amazon. I bet you it's like $3 for a dozen of these, and I'll never have that problem again. Well, it turns out it was $8 for just one. And I just could not stomach spending $8 for 5 cents in plastic. And yeah, I guess I probably could have gone to the bank. I don't know, are there still banks? Can you still actually walk into a bank? I can't remember the last time I've actually been in a bank. So yeah, I put a piece of packing tape on the top here, and that's how it lived for the last year. Well, it's come back around to that time of year to pay the property taxes again, so I grabbed the checkbook, and I was looking at it. I was thinking, wait a minute, can I 3D print one of these now? Now, I don't know how checkbooks are in the rest of the world, but here in the US, they all sort of follow the same format where you have like this top little part that you can kind of tuck your checkbook register in, and then this bottom part that your checkbook tucks into. And obviously I've printed a fake check here on the top, so you guys can't see my actual banking information. So they're pretty simple in design, but because they have these pockets that make everything kind of stay in there the way you want it, that typically wouldn't be something that we could 3D print. But I thought, wait a minute, couldn't we duplicate these pockets with the same method that we used for the TPU bellows? Just have 2 layers of TPU with a thin layer of PLA in between it. So let's try that. All right, and here is the design that I came up with for this. And I'm not going to spend a whole lot of time talking about this because I pretty much just brought the existing checkbook cover up here to my desk, pulled out my calipers, measured everything, and just duplicated the design. And because this whole thing is so thin, it's really hard to see, but if I do zoom all the way in here, you can see there is actually a gap between this layer here and this pocket cover here. And I've been doing this with designing it to the exact thickness of either 1 or 2 layers. So figure out what your layer thickness is going to be for your print and design your gap to be exactly 1 or 2 layers. It's either going to be a single interface layer or the top and the bottom interface layer, but you don't want any actual like sparse support layers in between those. So, all right, I'm going to pull this into the slicer. I'm going to get this sliced up and let's print it out. All right, our print is complete and came out pretty nice. There's maybe some areas here, if I look real close, where it's a little under extruded or maybe a little over extruded, like right there. I don't think that's going to stop this from working. And I didn't even consider it at the time, but the texture from the PEI bed actually gives a nice texture on this as well. That looks pretty cool. So let's see if we can remove these parts, our PLA interface layers, and see if this stuff fits. All right, I probably should have done more than 1 layer for this part up here. It is super, super thin, and I did get a little aggressive over here when popping out the support material, and it split. But other than that, that all came out nice. Let's see if the stuff fits in there. All right, well, that worked really well. I really like the thickness that I made this little tab up here. I should have made the thickness of that pocket the same, and we wouldn't have had that tear out on the side. But I mean, it doesn't actually stop me from using it, though you guys know that I'll probably reprint another one because it'll bother me just even knowing that that little tear is there. Checkbook fits nice down in the bottom, and I'm sure this will get sort of a little bit of memory to it on the corner there and sort of stay folded after it is in my bank bag for a little bit. But that worked out really, really well. So let's try something else. I've got another idea. Let me go get some tools. All right, these are all of my Noga deburring tools that I use for deburring 3D prints. And right now they just live in this empty filament box. And I think I've shown these on the channel before. At least for sure you guys have seen this one. I bet you everyone watching this video has either this deburring tool or a copy of this one. These are pretty ubiquitous. The other ones I'm not sure if I've shown you guys. This is a blind deburring tool for blind holes. As long as the shaft will fit up into the hole, you can then push this down at the bottom and it pushes this guy into place, and then you can kind of pull downward and rotate it, and it deburrs from the inside. And this one has a bunch of different attachments. These go on to the end. Actually, this extends. It's like adjustable. And then this goes onto the end. So you guys can probably imagine how that's used. If you have like something round like this, say that you wanted to deburr, it just rotates around that and deburrs it easily in one shot. And then these do the same thing for just regular inside holes. These pretty much do the same thing that this does. It's just if you have a hole that is in the range of either one of these, it makes it a lot easier because, again, you're just pushing in and rotating it around. It just deburrs it real fast rather than having to kind of go all around with this guy. I'll put a link to this stuff down in the description of the video. I bet you a lot of you guys have not seen these other ones, even if you're using one of these today. What I want to try is, what if we made like a tool roll for these? Usually they're made out of fabric, and I guess we could sew one up. I think Mrs. FPF has a sewing machine. But what if we made one out of TPU that these guys all slid into, that all these parts fit into? Maybe like with a top that folded over. I guess maybe we might not have that much room on the bed. And then we could roll it up. Put a little Velcro around it or something like that, and just have all these kind of organized rather than just being loose in that box. So I'm going to get some measurements for each one of these and then see what I can draw up in CAD. And already I'm a little concerned here because these handles are pretty thick. This might not have been the best choice. This might be a better choice for tools that are more like this shape, like, you know, I don't know, maybe like jeweler's screwdrivers or something. I'm a little worried how big these pockets are going to have to be for the handles on these Noga tools. These are pretty big, but let's see what we can figure out. All right, and here is the initial design that I came up with for the tool roll. And I'm really just guessing at a lot of these dimensions. I kind of started with the maximum printable area that I could use on the H2D without going into the nozzle exclusion zones on either side, since this is going to be a multi-material print. And I just kind of guessed, honestly, at the sizes of the pockets. You can see there's one pocket here and then one pocket here for the two large Noga handles. Two smaller pockets here for the accessories that are not going to be mounted on the larger of the Noga handles. And then a small sort of tall pocket here for that blind deburring tool. I also decided to try something else new here. If I flip this over, you can see I went and I grabbed the Noga logo, and then I extruded that down by 1 layer height. And what I'm thinking is going to happen here is it should print a single layer of the support interface material and then put TPU over top of that. And if that works, we should be able to basically peel out the support interface material from that embossed area, and we'll end up with just an embossed logo. And I position that like that, so imagine that flap folding over, so the logo will then be right side up as we're looking at it with that flap down over the rest of this. So yeah, I guess we're trying kind of two new things here. First of all, just kind of creating a tool roll, and then also this idea of embossing the logo into the underside of TPU. So, all right, let me get this sliced up, and I guess let's go for it. All right, well, that didn't go very well. I'm not actually sure what went wrong here. I can see the beginning of the concentric interface layer there with the PLA, and then it just kind of stopped sticking. This wasn't a total loss. We did learn some stuff. The idea of having like that layer of PLA down first to kind of give us like a bit of like an embossed logo, that worked really well. I'm actually really happy with that. I don't like that we can still see it on the other side. I mean, it's not that bad, but you can make it out. I would prefer that you couldn't see anything from this side at all. And this does look, you know, looking at the camera screen here, this looks really, really over extruded up here. It's not that bad. That's just the reflection. It is over extruded, don't get me wrong, but it's not as bad as it looks. You know, this was a fresh roll of SaneSmart TPU. I didn't mention, because I know I was originally doing the testing on the bellows in SaneSmart TPU. I ran out, and this was done in Sunlu. This checkbook cover was done in the last of the SaneSmart black TPU that I had. And I ordered another roll of SaneSmart because I do like the SaneSmart stuff. So this is a fresh roll of SaneSmart. It seemed to be sealed really well, so I didn't dry it for that long. I just wanted to get on with the video. So I think I dried this for 3 hours. Maybe that wasn't long enough. So I'm going to dry the filament overnight and give it a full 10 hours at 145 degrees Fahrenheit and see if that makes a difference. Okay, so it looks like we had 2 problems. This came out really, really clean. There's definitely no extrusion issues with this at all, having dried the filament overnight. I also modified the design a little bit. The other one was a little bit thicker than it needed to be. I wanted it to be more flexible, so this one is 1 layer thinner overall. Also shrunk the logo a little bit. That still looks really good there, sort of that embossed look. We can see the logo through this side even a little bit more now with 1 less layer, but the PLA still didn't stick. The same problem again. You could kind of see a little bit of residue from the PLA on there, but it just did not stick. So I don't know what's going on here. I think let's give it one more try. And if that doesn't work, we're gonna have to try something else. All right, I'm starting to get frustrated. I do not know why the PLA will not stick to this TPU. I didn't have any issue with this at all before. It's like oil and water. It just does not want to stick to it. I also decreased the thickness of this by 1 more layer again. And I think actually that's plenty thick enough. And I really like how flexible this is. Our logo still looks great from this side, but now we can really see it coming through from this side because there's only a single layer of TPU over top of where the PLA was to emboss that logo. But I do still like that thickness, so we'll probably stick with that. I don't know what to do here. So I didn't save the spool from the last of the black SaneSmart TPU that I had, but this is a roll of the old gray stuff that I had, and it was like the same generation spool as this, same label type. These labels never stay on when you dry this filament. They always kind of heat up and start to peel off. The new rolls are cardboard, and they're the nice cardboard rolls with like the edges covered over so they don't make a mess. Maybe they changed the formulation too. I don't know. I mean, it still has a really nice feel to it. If anything, it might even feel nicer than this stuff. Yeah, it actually, I guess it does feel a little bit different. The sheen kind of looks, maybe not. On the camera screen, the sheen looks the same to me, but it does feel slightly different. Maybe they changed the formulation. So I'm not sure what to do here. I'm scratching my head a little bit. I'll bring you guys back. Well, it's the next day and I've made some progress. First thing I did was stop printing the whole full-size print because that is a complete waste of time and materials, and I printed just like a small section of the print as a test. This is still the same new roll of black SaneSmart TPU. I was tempted to switch it because I do have the Sunlu in black, but I really wanted to get this to work with the SaneSmart. That is my preferred TPU filament. I think it just has a bit nicer of a feel to it, matter of preference. And you can see I've already removed the interface material here just to test this pocket and worked out just fine. The material that I used on this one is the Bambu Lab PETG HF. I remember from our previous test that the TPU seemed to stick to the PETG a bit better, but the PLA also stuck to it fine, and you know we want to be able to remove the interface layers, so PLA seemed the better choice. But when it wasn't sticking, I thought, let's try the PETG. And I don't know if regular PETG would do the same thing. I know the PETG HF formula is a little bit different, but that's the only PETG that I had dry, so that's what I went with. And yeah, it works out nice. It doesn't release quite as nice as the PLA, but it sticks to this, which is what we needed. So, all right, I'm gonna try running a full-size one of these with, again, the SaneSmart Black TPU and the PETG HF as the interface layer. All right, well that completed successfully, and I've already gone and removed all of the interface material from in here. It is a little bit harder to get it out, like I said, than the PLA, but I was able to remove it even from these small pockets here without any issue. And yeah, same thing. I mean, with this thickness of material, I really don't like how the embossed logo shows through from the other side, but yeah, it sure does look good from that side. So probably going to keep that. But let's grab the Noga tools and see if they fit in here. All right, let's start with our inside deburring tool. Fits in there nice. Let's see, this one goes in the short one. This one I made taller because I was thinking that I would want to be able to put it in here with one of these guys installed. And then these two guys go in our little pockets down here. I stopped to see why my pocket keeps buzzing, and it looks like EM just joined the Patreon. Thanks, EM. And my print on the X1C is done, but you guys can't see that yet. All right, let's get this last one in. Huh. Yeah, I don't really like, this is too thick for this depth pocket. And you can see this doesn't fold over all the way. I wonder if we take this out of here. That's better. This might actually be better going in this way too. Probably easier to put in. Yeah, actually that works out better. Roll it. It actually does roll up. All right, this is close. I think what I want to do is, I think I want this pocket to be a little taller, and this one to be a little shorter. So maybe we'll split the difference and just make these pockets both the same length. And let's just make 3 little pockets for these guys. We could probably put them kind of more in line with each other. Maybe up here, so that we don't have them all the way down at the bottom where the flap doesn't cover it. All right, let me go make those adjustments. I'm going to print one more of these, and I'll bring you guys back. All right, our final print is done. How do I know this is our final print? Well, while this one was printing, I actually edited pretty much the rest of this video because it's pretty late now on Friday. In fact, if you're watching this video shortly after it came out, yeah, what you're seeing right now is probably no more than an hour or two ago. And I left it on the sheet because I figured part of this process is you guys seeing how I actually get this off of the sheet. It is a bit tricky to get this off. TPU sticks to PEI sheets really, really well. And yeah, I can hear you guys down in the comments. If you spray the sheet with hairspray or hit it with a glue stick first, that does work as a release agent. It can also make it not stick in some places or stick inconsistently. And that has some thickness to it as well. And sometimes that actually shows up rather than getting the nice texture of the PEI sheet. So I don't put anything down on my PEI sheet first. I start with a completely clean PEI sheet. Let me go grab my tools. I'm going to show you how I get this off. So there's 3 things I use to get this off. The first one is IPA. And I don't think you actually need the super premium pure stuff for this. This just happened to be what I have. I think the 90% stuff from the grocery store would be just fine. So you're gonna need some IPA. Second thing is just a plain old chip brush. These are cheap, although I've been using this same one for this for probably over a year. So it's not like they really wear out doing this. The last item you're gonna need is a thin spring steel scraper. And I'll put a link to the closest one I can find to this on Amazon. Unfortunately, it's not going to be this one because this one is probably, no joke, over 100 years old. This is one of those tools that was passed down to me from someone who had it passed down to them, from someone who had it passed down. It's one of those. So I really like this one, not just because of the heritage of it, but the quality of the spring steel on this one is really, really good. It's super thin. And I can push quite hard with this without it actually bending and kinking. It's got maybe like a little bit of a kink in one spot there. I don't know if I did that or if it was like that before. But yeah, don't skimp on a spring steel scraper. I do have another one of these that I did purchase. I will go find that one from my purchase history. Admittedly, I still like this one better, which is why this one's in my 3D printing toolkit, and the one that I bought that's like it went back in my tool bag where this one came out of. But yeah, don't skimp on a good scraper. So I start by taking my brush and dipping it down in the alcohol. And this used to be quite a bit more full, and this was easier to do. Now I have to kind of tilt it over on its side. And I just take the brush and I paint the alcohol all along the edge. And I'll do it here on our prime tower as well. I'll just put a bunch over top of it. What this is going to do is it's going to wick underneath this print by just a little bit. If you've ever tried to remove TPU from a PEI sheet, it's like impossible. It's glued on there. The amount of pressure that you have to apply to get it to come off, you're either going to separate the PEI from the sheet or you're going to damage your print. And that says a lot because TPU is pretty tough. But I just put this stuff on there and I let it sit for like a minute or two, just so that it starts to wick underneath the print. And I'm going to move you guys out of the way so that I can work on this from straight on. Now once that has had maybe, I don't know, I usually give it 30 seconds to start wicking under there. Usually I can get a corner up with the knife. Yeah, so I'm able to get that started under there, and then I can take the knife, and depending, I don't know what direction this infill started. It actually feels a little bit harder than it should be from that end, so let me try this corner here. And just even pressure. You can feel the difference as that alcohol wicks underneath there. Like if I push really hard, it's not going to go any faster. It takes a little time for that alcohol that's sort of running on the edge of the knife to work under and release. This goes really fast for small prints. Like if I had a TPU print that was, like the size of this, you can get underneath and have it off in 10 seconds. Larger prints like this, it does take a little time, but I'll still take that for the perfect finish. Versus using like hairspray or glue stick on it. All right, as you can see, there is zero damage to the sheet, and this is ready to go again. Now that was pretty time consuming to get that off, but you can see the end product is a really, really nice textured surface on the back of this TPU. So I'm curious to hear down in the comments if you guys have any ideas on a better way to get this TPU to release from the PEI sheet that doesn't involve putting a release agent on the sheet first. Or if you have a release agent you use that doesn't leave any residue, like there's nothing to clean off of the sheet or the part and doesn't impact the, your part picking up the texture from the sheet, I'd love to hear about it. But this does work, and for smaller TPU prints, it actually works really, really well. Oh, I did make one other design change on this. I thinned out a section of it right where I thought this was going to fold over. Oh yeah, look at that. That actually works out pretty nice. We could probably kind of crease that there, and that'll stay folded over a lot easier. All right, we got to get the PETG out of here. You can see the PETG does not stick to the surface of the TPU as well as the TPU sticks to the PETG. Like I can always get my finger in the back of these pockets easier than I can get the PETG part separated from the TPU above it. This is where this tool also comes in handy to get these started. So let me get all of these started, and then I'll show you how I actually get that support material out of there. All right, so now that I've got all of these started, the best way that I have found to actually get the support material out, and for these big pockets, I could probably just do it with my thumb and forefinger, but I'm going to show you here anyway with the pliers. I'll get like a long pair of needle nose pliers, and I'll get, if you see there, I have the pliers over the support material, and I'll just take the pliers and I'll rotate them. And what happens is it wraps that support material around the pliers and tends to break it out of all the little corner spots that are tricky to get to. I'll just keep rotating them. You want to be careful. If it's really stuck in some of those corners, you don't want to tear this. We did make this pretty thin. I think this is only 2 layers thick at this point. Of course, now that I'm trying to do this on camera, this is going to be the hardest one ever to remove. Usually they come out pretty easy. This one, there might have been like a little over extrusion. Maybe on the PETG, it really seems stuck down here in this corner. All right, it took me like a minute to get this last little tiny piece all the way out of the corner down here. It's always harder to do stuff on camera like this, but PLA is definitely a better interface material if it's compatible with your TPU. So try that first. Don't use PETG unless you have to. I mean, I'm getting it out, and I will, I'll do the rest of these off camera. Watch, the rest of these are probably going to come right out now. Yeah, that one's sticking in there a little bit in the corners too. All right, let me get the rest of these out. I'll bring you guys back. Of course, as soon as I turned the camera off, this one came out in one piece in like 5 seconds. All right, well, with the exception of just one of these little small pockets, the rest of these all came out really easy. So let's get this cleaned up. Let's see if this stuff fits. All right, well, that worked out pretty well. It doesn't roll up quite as nice as I'd like. It probably needs to be a little bit longer. These are also really fat. I think if we had all tools that were more like the size of this, I think it would roll up really well. These Noga tools were probably not the best test for this, but I think as a proof of concept, this still worked out pretty well. And I mean, it works even like this, just sort of folded over. And I really do like the embossed look of that. And the contrast of the textured surface that was down on the PEI sheet with the glossy surface of the rest of this. Well, guys, I think we got to leave this one here. Hopefully seeing this proof of concept of this tool row for my Noga deburring tools and the proof of concept of the checkbook cover kind of get the gears turning in your own heads as far as different ways that you can use not even just flexible filaments, but filaments in general in the 3D printing process that are a little bit outside the box now that we're sort of in this era of multi-tool head machines. I was chatting with my patrons about this earlier today. Snapmaker had a dual extruder machine out for a while. Prusa obviously has the XL. I think we're now entering the era with the launch of the Bambu H2D where we're going to see a lot more machines with multiple tool heads that are much more affordable. And on that note, I think, especially if you're in the US, the price did drop back down on the Bambu Lab H2D. So if you are considering a multi-extruder or multi-tool head machine, I am really happy with the H2D. And I'll put a link down in the description of this video for that machine if you're interested in picking one up. So we're getting to that part of the video where you guys are probably already trying to figure out what thumbnail you're going to click on, what video you're going to watch next. I get it. I do the same thing. But I'm going to ask you for a favor. Take a second. Go down in the comments and tell me what ideas this gives you. How does it impact the 3D printing projects that you might have in the works, or maybe some ideas that you had that you just couldn't figure out how to 3D print them, kind of like the checkbook. I never even considered 3D printing this before because I just figured it couldn't be done. I'm really curious to hear what you guys are thinking. And if you enjoyed this video, while you're down there, take a second, hit the like button. That really helps the channel out as well. And guys, as always, thanks for hanging out in the shop with me for this week's design and video. I really appreciate being able to share this stuff with you guys. And if this is by chance your first time here, this is all we do. It's all functional prints. I don't always do proof of concept stuff like this. Usually it's just fixing something that I've got laying around or adding a feature or functionality or solving a problem around the shop here or out in the yard or around the house. But if you enjoy that sort of thing, you like more of those functional engineering type videos instead of just whatever new multicolored garbage there is to print for that week, check out some of the other videos on the channel. And if you like what you see, hit that subscribe button. And guys, if you do, I'll see you next Friday.